All right, time to finish up this quadratic review pack. I'm going to pick up on number 17. Other vocabulary words for solutions: zeros, x-intercepts, just plain old intercepts, which is actually x-intercepts, but intercepts. What else? Zeros, roots, and solutions. There you go. You needed to have two. Know them all. Rationalize the denominator means that we can't leave any radicals in the denominator. I'm going to multiply this fraction by 1 in the form of square root 3 over square root 3. 7 square root of 3 in the numerator, square root of 3 times 3 in the denominator, 7 root 3 all over 3. Number 19, rationalize the denominator, multiply by 1. 6 radical 7 over 2 times 7. From radical 7. 6 radical 7 over 14. I need to reduce 6/14. They're both divisible by 2. 3 radical 7 over 7. Number 20. Number 20, in order to rationalize this denominator, we need to get the radical out of the denominator, which is going to be easy here. 5 square root of 4 is 5 times 2. This is equal to 4 plus 2 radical 3 all over 5 times 2, which is 10. And actually, I need to stop right here and simplify. Divide by 2. I'm actually going to divide by 10. 4 divided by 10 and 2 divided by 10. I'm going to simplify this down to 2/5 plus radical 3. 2 plus radical 3 all over 5. 4 divided by 10. 4 divided by 2 is 2. 2 divided by 2 is 1. 10 divided by 2 is 5. I divided 2 out of that. Going to move on to 21. I'm getting tired, so I need to keep going. Rewrite the quadratic in standard form using simplifying techniques. The first thing I'm going to do is multiply x minus 3 times x minus 3. Fill in my box. My area model is always helpful, positive 9. I'm going to come in now and I'm going to replace that x minus 3 squared, the quantity x minus 3 squared, with its trinomial, which is x squared minus 6x plus 9, and now subtract 5 from that. I'm going to distribute 2x minus 12x plus 18, and in the end I need to subtract 5. And if I look at simplifying by combining like terms further, 18 minus 5, I'm going to just change this to the 13 that it is. There you go. Let me multiply these binomials together, keep them simple. I don't want to distribute that negative 3 into one of them yet. It's easier to do my multiplication here. X squared minus 3x, positive 4x, negative 12. I'm going to bring that into this equation and replace the two binomials with x squared plus x minus 12. Distribute my negative 3, x squared plus minus 3x plus 36. Oh, lost a square back there. Cool. Number 23, has rocks thrown from the top of a building. Got our equation. How long after the rock is thrown is it 370 feet from the ground? When is the distance 370? Solving for t. As I'm writing this, I'm already thinking that I want to use the quadratic formula rather than any of our other solving methods. I'm going to take 370 away from both sides. Taking 370 away from both sides leaves me with simply 12 as my constant, or my c value. A is negative 16, b is negative 4, c is 12. When I go into my quadratic formula, I'm going to start up here. I always take up a ton of room. In order to find out what this distance is, I'm going to take my opposite of b, plus or minus radical b squared minus 4 times a times c all over 2 times my a value. I'm going to come down here now and start doing my solving. 4 plus or minus, it's all going to be over negative 32. Radical 16 plus 4 times 16 times 12, 768. 16 plus 768 under the radical is 784. Square root of 784 is 28. So I'm looking at 4 plus or minus 28, all divided by negative 32. 4 plus 28 divided by negative 32 is going to result in negative 1. 4 minus 28 divided by negative 32 is going to result in, let me use my calculator, 3/4. How long? It's going to take 3/4 of a second. Moving on to number 24. Rocket carrying fireworks. Blah, blah, blah. What's the height of the rocket after 1.5 seconds? All I want to do is put in 1.5 for t. And find the solution. As I'm putting this into my calculator and thinking ahead here at B. In B, maximum height is going to be the y value of the vertex. I'm going to go get that next for part B. Just working my calculator right now to get the actual solution to A. And I believe it's 140 feet. I put that in pretty quickly. Negative 16 times 1. This is looking good. Got it. What's the maximum height? Well, what I'm going to do first is find the x value of the vertex. Negative b all over 2a. This is negative 64 over negative 32. So the maximum height happens 2 seconds in to the launch. Let me evaluate this function. I'm going to use some function notation. H of 2, negative 16 times 2 squared, plus 64 times 2, plus 80. Going into my calculator, negative 16 times 4, plus 64 times 2, plus 80. The maximum height is 144 feet. The vertex again happened at 144. How long will it take for the rocket to hit 128 feet? And I'm going to stop here because I need more paper to finish this, and I'll just add my last video for 24 through to finish 24 through 30.